All right, so we'll do some practice together. And again, I really encourage you to use this simotter.org um, website for practicing additionally on your own. But we can do ammonia. So if you look at ammonia, right, it has a C3, has 3 sigma V's. And so if we're going to go use our flow chart to figure that out, we know it's not a special group. It's not linear, super high symmetry, or super low symmetry. So we're going to go this way. And our flow chart says, is there a C2 perpendicular to Cn? Well, all we've identified here is a C3. There's no perpendicular C2. That would be somewhere here, and that would, take this umbrella-shaped molecule and invert it. So it'd be like an upside-down umbrella, which would look different, right? So there's no perpendicular C2s. Are there any mirror planes? Yes, there's 3 of them, and they all contain the principal rotation axis. So yes, there's mirror planes. Are there mirror planes perpendicular? No, there's no mirror plane like in here. Again, that would invert the umbrella up. So that gets us no, and that gets us a CNV. So because we have a C3, this would be called C3V. All right, let's do this. Trans 1,2-dichloroethylene molecule looks like this. It's a planar molecule. So it's going to have a mirror plane within the plane of the molecule. It has a C2 going right like that. Why is that? Well, this 180 degrees will go to there, okay? And this 180 degrees will go there. So those would both interconvert, and the carbons would also interconvert to one another, okay? As a sigma H, why is it an H? Because it's a horizontal mirror plane. It's perpendicular to the C2. It's within the plane of the molecule. And it also has an inversion, actually. But you don't need to, nowhere on this chart does it ask you for inversion, so you don't really need to look for inversion. So what would we do? We'd say, okay, no, we're not a special group. We're not linear or very high or very low symmetry. Usually we're not going to be. Do we have a C2 perpendicular to Cn? No, we only have one C2. There's no perpendicular C2 like here or anything like that, or here, so there's no. Okay, so the answer is no. Sigma H, do we have any? Yes, we had a sigma. Sigma, do we have any? Yes. Was it perpendicular to the Cn? Yeah, it was. It was sigma H. That's why we called it sigma H. So yes. So it's going to be CNH because we have C2. This is called a C2H. So this will be the C2H group. Let's do this one. This is an isomer of osmium complex with 3 chlorines and 3 carbon monoxides. So it has a C2. It has 2 sigma V's, okay? And so this is going to make it end up being C2V. Why is that? Again, it's not a special group. So there was only one C2 there, so there's no additional C2 that was perpendicular. So that gets us to this branch. There was sigmas, right? And there are sigma V's. So we're yes, and they were not perpendicular. They were not sigma H's. So we went no, and we're C2 CNV. So because we had a C2, it's C2V. Bromochlorofluoromethane. That looks like this, and that has nothing. So it's going to be C1. So that's going to be, down here in your very high symmetry, no, C1. It doesn't have an inversion. If it did and had nothing else, it'd be CI. If it had a mirror plane and nothing else, it'd be CS. But it has nothing at all except identity, so it's C1. This is a chiral molecule because of that. And we'll talk a little bit about that in the